Hello everyone, this is Billy Younger. I just wanted to take a moment and show you guys how to calculate a dot product. Next video I'm going to make is showing you how to calculate a cross product, and then after that I'm going to show you how to calculate a divergence, and then after that I'm going to show you how to calculate a curl. Obviously you can't really do a divergence without first doing a dot product, and similarly you can't do a curl without first doing a cross product. So let us get started. I'm going to just use two arbitrary vectors A and B, where A has an X component AX, a Y component AY, and Z component AZ, and B has a similarly defined one. So let's get started. So if I define the vector A as AX I hat plus AY J hat plus AZ K hat, which is actually a lot quicker to write it with this kind of notation where we just do A sub X, A sub Y, A sub Z, like that. When you put it in that notation, most people recognize that as a vector, and they recognize the first one as the X component, the second Y component is Z component. Similarly, I will define B as BX, BY, BZ, and the dot product actually has a couple different ways of calculating it. A dot B is actually equal to the magnitude of A times the magnitude of B times the cosine of the angle between them, and that angle is defined as A B, and theta would be there, where A and B are, of course, tail to tail. Obviously, that angle can vary from 0 all the way up to pi or 2 pi, in which case it can be positive and negative. But there's another definition specifically that I'd like to use, because normally you can use this other definition to get this side. And then, of course, knowing A, you can use the Pythagorean theorem to calculate the magnitude of A, use the Pythagorean theorem to calculate the magnitude of B, and then you can use this to determine the actual angle between two vectors. That's often done in introductory solid state courses and stuff like that. But it's also useful just every day if you're trying to do, for instance, molding around the top of a house or something like that, or on the top of a room. You can actually use that to figure out angles, or at least I have. So anyways, the other definition is A dot B is equal to AX, AY, AZ dotted with BX, BY, BZ, and in this case, this is just a linear operator, so you're literally just going to take and set this equal to AX I hat dotted with a BX I hat. Then you're going to take AX and let it hit the BY. You say plus AX I hat dotted with BY J hat. And then you take AX I hat dotted with BZ K hat. And you take now AY J hat dotted with BX I hat plus AY J hat dotted with BY J hat plus AY J hat dotted with BZ K hat, and then plus AZ K hat dotted with BX I hat plus AZ K hat dotted with BY J hat plus AZ K hat dotted with BZ K hat. Now, if we go back to our original definition, these hat vectors, remember, these are linear operators, this dot product is. So that means you can pull out this number BX and this number AX, pull out in front, and then you're just going to do I hat dot I hat. Same thing here, you'll do I hat dot J hat. Same thing here, you'll do I hat dot J dot k hat. But according to this, a dot b, for instance, let's say I hat dot I hat would actually equal 1 times 1 times the cosine of 0 degrees. Of course, that's just 1. And then I hat dot j hat would be 1 times the cosine. Now they're 90 degrees apart. So in fact, that gives me 0. And in fact, what we find out is I hat dot j hat gives you 0. I hat dot k hat gives you 0. J hat dot I hat gives you 0. J hat dot k hat gives you 0. K hat dot x hat gives you 0. K hat dot y hat gives you 0. And then all that's left is these diagonals. But just like I hat dot I hat gave us 1, j hat dot j hat would be 1 cosine 0, and k hat dot k hat would be 1 cosine 0. So these all give you 1. So you ultimately just have ax times bx times 1 plus a y b y times 1 plus a z b z times 1, which is just ax bx plus a y by plus a z bz. That's it. That's the dot product. Easy peasy. Hope that helped.